there is life on Mars.
In the vast Martian desert, a monumental discovery has sent shockwaves through the scientific community. NASA has stumbled upon a revelation of such profound significance that it has left the world in awe. As we await more details, a pressing question arises. What exactly did NASA uncover on Mars that has captured the world's attention? Could it be an enigmatic message from an ancient civilization, etched into the Martian landscape? Perhaps it's a relic from a bygone era, a doorway to uncharted knowledge and mysteries. Alternatively, it might be a foreboding signal, hinting at a cosmic truth so unsettling that it challenges our very understanding. Join us as we delve into the mystery of NASA's terrifying Martian discovery. The Martian Water Mystery. Individuals often express curious statements, but when these remarks emanate from a scientist, we anticipate them to be grounded in facts and rigorous study. Consequently, when scientists suggested the possibility of life from Mars, their words held considerable weight in our collective beliefs. However, what prompted this notion of potential inhabitants, be they extraterrestrial beings or other life forms, residing on Mars? The answer lies in the presence of water. Water, the essential element for life as we know it on Earth, was discovered on Mars. This discovery significantly intrigued astrobiologists, who began contemplating whether water, known to facilitate life's evolution on our home planet, could also have played a similar role on our celestial neighbor within the Milky Way. NASA's Mars mission in 2020, despite having multifaceted objectives such as gathering geological samples and studying the Martian landscape, primarily aimed to investigate the historical existence of life on Mars, or the potential for its continued existence. It was logical to focus on locations where experts believed water once existed, as it is widely accepted that most life forms tend to cluster around bodies of water. Hence, the Jezero crater, which aptly means water in Scandinavian, was chosen as the landing site for the Perseverance rover in 2021. This decision was influenced by the substantial evidence suggesting that this massive clay crater had, at some point in its history, been a substantial lake. In February 2021, Perseverance successfully touched down in this crater, and the landing site was christened the Octavia E. Butler Landing Site in honor of the late African-American science fiction author. Perseverance's organic matter findings. NASA scientists believe that Mars's lengthiest river once flowed through the Jezero crater, and they hypothesized that a long-standing lake existed there. According to their estimations, Mars, often referred to as the Red Planet, has had a lifespan of approximately 4.6 billion years, similar to Earth. This leads to the intriguing possibility of either past or present life on Mars. To investigate this, researchers are utilizing a tool known as Sherlock, a spectrometer that employs ultraviolet technology to search for organics and chemicals in areas where life may have existed. This device was specifically designed for NASA's Perseverance rover to detect organic matter in the samples it has collected from Mars. Why is NASA interested in biological matter? Because carbon-based materials, which are essential for life, can only originate from waste, or the decomposed remains of plants and animals. On September 15th, mission planners informed us that the Perseverance rover had made a significant discovery of biological material during its exploration of an 8-mile stretch within the Jezero crater. The rover collected samples from various ridges surrounding the crater, ultimately identifying the highest concentration of organic matter in samples obtained from Skinner's Ridge and Wildcat Ridge. Sunanda Sharma, an instrument scientist involved in the Perseverance mission, later emphasized that the substantial presence of organic matter is a promising indicator for the mission's primary objective, which is the search for signs of life on Mars. The Perseverance rover possesses 43 sample tubes, with plans to retain only 25 of them. Notably, the rover is currently safeguarding the biological matter, which will subsequently be transferred to the sample return lander. This material will then be transported back to Earth, where scientists will conduct in-depth studies to gain further insights. Notably, NASA and the European Space Agency are collaborating on this ambitious endeavor, denoted as ALH 8401. The Martian rock that shook science, The discovery of organic matter on Mars by the Perseverance rover was undoubtedly significant. However, it pales in comparison to the initial excitement that enveloped the scientific community in 1996 when David McKay and his team claimed to have uncovered evidence of life on the Martian surface. This pivotal moment hinged on a rather unassuming rock, known as ALH 84001, which had journeyed from Mars to Antarctica, where it was ultimately discovered by a group of dedicated scientists. McKay and his colleagues proposed that this rock fragment was a relic from Mars, precipitated through space and fortuitously deposited in the snowy expanse of Antarctica. McKay's subsequent presentation of this extraterrestrial rock to a panel of experts for their deliberation on the potential existence of life on Mars did not yield a unanimous consensus. To the surprise of no one, doubts emerged not only among the general populace, but also within the ranks of McKay's fellow scientists. William Shupp, for instance, maintained a skeptical stance, contending that the significance attributed to this unassuming rock was exaggerated. He asserted that while the discovery of organic matter on Mars was undeniably noteworthy, it fell short of conclusive proof regarding the existence of life on the red planet. A 3.6-billion-year-old puzzle. Presently, contemporary scientific opinion is divided, with a 75-25 split regarding the likelihood of past life on Mars. Most scientists propose that life may have existed on the Martian surface roughly 3.6 billion years ago, coinciding with the drying of the Jezero crater. However, there is a minority perspective, comprising a small single-digit faction, which argues against the presence of any past life on Mars. The current mission of the Percy rover, equipped with cameras, microphones, and samplers, is to investigate this conundrum by collecting over 43 samples of Martian material, monitoring frequency waves, checking for the presence of oxygen, and performing various other analyses. This endeavor commenced on February 2021 with Percy's arrival on Mars, accompanied by a smaller drone named Ingenuity. Ingenuity's primary objective has been to gather samples and data from the planet's atmosphere, having completed 29 successful trips and setting a record for the longest flight on Mars by a small margin. The implications of Percy's potential discovery of life on Mars are profound. While the notion of a Martian fossil might initially invoke science fiction scenarios, the reality would necessitate a measured and deliberate response. Space agencies and the global community would face critical decisions and uncharted discussions. One of the foremost considerations would undoubtedly be the impact on life here on Earth. The discovery of Martian life would have profound implications, stirring questions about our existence and the potential for life beyond our planet. Mars habitability and SpaceX's ascent. The Mars 2020 project's objective of searching for signs of life suggests the potential existence of life beyond Earth. This notion prompts contemplation about the possibility of inhabitants on other planets, leading diverse lives with distinct survival strategies. The presence or historical existence of life on Mars prompts intriguing questions regarding its origins, a topic that has already garnered substantial attention. Elon Musk, a billionaire entrepreneur, consistently engages in ventures that may appear frivolous to some, fostering uncertainty about the seriousness of his endeavors due to his prolific Twitter activity. Nevertheless, Musk's unorthodox approach and revolutionary mindset have been instrumental in propelling him to his current status. It's worth noting that the recent findings by the Perseverance rover have ignited fresh discussions about the potential habitability of Mars, reviving an idea first introduced in 1996. This concept provided Musk with the impetus to establish SpaceX, an organization dedicated to crafting innovations for space exploration. A central objective of SpaceX since its inception in 2002 has been the pursuit of human colonization on Mars. As a result, individuals have eagerly expressed interest in being part of the pioneering group to inhabit this distant world, with hopes of potential economic opportunities tied to this endeavor. Why permanent residence is unlikely. Scientists suggest that people shouldn't establish permanent residence on Mars. Even in the presence of potential life on the red planet, it is unlikely to provide sufficient incentive for humans to abandon Earth. This reluctance is primarily attributed to the harsh environmental conditions on Mars, which fundamentally differ from those on Earth. The challenges stem from Mars's limited water resources, its inability to support life to the extent Earth does, as well as its inhospitable terrain and atmosphere. The unsuitability for human habitation on Mars can be primarily attributed to the absence of breathable air and readily available water, as well as the substantial cosmic radiation levels, making survival nearly impossible. This perspective challenges the narrative presented in the 25th movie, The Martian, which portrays the protagonist's survival on Mars. This cinematic portrayal often perpetuates misconceptions about Martians' appearance, emphasizing exaggerated and stereotypical features such as wrinkled skin and bug-like eyes. These depictions are more a product of Hollywood's sensationalism than an accurate reflection of reality. However, should there be actual Martians, it is reasonable to assume that they would have evolved differently from humans due to unique environmental pressures. They might be larger than humans, a potential consequence of environmental influences rather than genetics. Their height could have been influenced by factors such as diet and the need to forage for food in a challenging environment. The presence of wrinkles and prune-like features, often associated with Martians in popular culture, is a matter of conjecture. The actual appearance of Martians, if they exist, remains uncertain and cannot be definitively characterized. Methane spikes and alien life speculations. One of the most fascinating discoveries on Mars centers around the detection of intermittent increases in methane levels in the planet's atmosphere. Both NASA and Elon Musk's endeavors have provided evidence of periodic releases of methane gas, which could be a potential sign of ongoing biological or geological processes. Methane, although found in small amounts in the Martian atmosphere, has a relatively short lifespan. Its detection suggests the presence of ongoing sources that might be linked to either microbial life or geological phenomena, such as volcanic activity. This finding has sparked intense speculation about the possibility of past or even current extraterrestrial life on Mars. The presence of methane on Mars, coupled with other factors like the discovery of organic compounds in soil samples, has fueled hopes of finding microbial life or remnants of ancient life forms. However, it's crucial to approach these speculations with caution, as non-biological processes such as chemical reactions could also explain the observed methane spikes. To unravel this mystery, future missions, including proposed sample return missions, will play a vital role. By collecting pristine samples from Mars and conducting in-depth analysis on Earth, scientists aim to determine the true origin of the detected methane and ascertain whether it indicates biological activity. The implications of discovering microbial life or evidence of past life on Mars are profound. Such a discovery would not only reshape our understanding of the potential for life beyond Earth, but also raise fundamental questions about the origins and evolution of life in the universe. The quest for signs of alien life continues to captivate scientists and enthusiasts alike, motivating us to uncover the secrets that Mars holds. As we await further investigations and breakthroughs, the detection of methane spikes on Mars tantalizes our imagination and underscores the importance of further exploration to unveil the truth behind these enigmatic signals. The chilling truth about temperatures. Mars is located approximately 222 billion kilometers from the Sun, while Earth is only about 148 billion kilometers away. Despite the common perception of Mars as an arid desert, it is in fact cooler than Earth. If Martians were devoid of body hair, they would likely experience discomfort and potential harm due to the lower temperatures. Moreover, the Martian environment might not have been conducive to sustaining their existence in the first place. The speculation about the bug-eyed issue among Martians remains a topic of discussion. It is posited that intense radiation could have resulted in vision impairment, or necessitated a change in their orbital path for safety. To definitively address these hypotheses, we can only await the possibility of encountering a genuine Martian along Perseus' trajectory. As part of NASA's Mars 2020 project, the car-sized Mars rover Perseverance has joined a lengthy lineage of rovers tasked with searching for signs of life on Mars. Thus far, the rover has demonstrated its worth by successfully collecting biological materials from the surface of Jezero crater. While this accomplishment may not decisively indicate the presence of life on Mars, it represents a significant step in the right direction. As Sharma aptly observed, Perseverance has spent 598 sols, equivalent to 653 Earth days on Mars. The robot is scheduled to return to Earth in 2033, once it has sufficiently explored the Martian surface and provided insights into the enduring question: is there life on Mars? Evidence of lethal radiation levels and toxic soil composition. Mars, due to its thin atmosphere and the absence of a robust magnetic field, exposes its surface to intense solar radiation. Thanks to the collaborative efforts of NASA and Elon Musk's ventures, we have discovered worrisome evidence of dangerously high radiation levels on Mars. Data collected by rovers and landers have revealed radiation levels that surpass what is considered safe for human exploration. The health risks associated with these elevated radiation doses are a substantial concern for upcoming manned missions to Mars. Consequently, the development of shielding mechanisms and advanced radiation protection technologies is imperative to ensure the success and safety of brave human explorers venturing onto the Martian terrain. In our pursuit of comprehending the potential habitability of Mars, scientists have unveiled a disconcerting revelation: the presence of toxic compounds in Martian soil. A thorough analysis of soil samples collected by Mars rovers and landers has disclosed the existence of various hazardous substances, including perchlorates. These perchlorates are exceedingly reactive chemicals that can adversely affect living organisms, including humans. The discovery of perchlorates in Martian soil raises significant concerns for future colonization endeavors and the cultivation of crops to support human existence. These compounds possess the capacity to impede plant growth and pose a danger to the well-being of astronauts who may inadvertently inhale or come into contact with the soil. Additionally, the toxicity of Martian soil underscores the formidable challenges in establishing a self-sustaining ecosystem on the planet and mitigating the risks associated with toxic soil. In response, scientists and engineers are pioneering innovative methods to decontaminate and prepare Martian soil for agriculture. Strategies like bioengineering and chemical treatments are under exploration to neutralize harmful compounds and render the soil more conducive to plant growth. These efforts are of paramount importance for ensuring the enduring viability of sustainable habitats on Mars. As we unravel the reality of Martian soil's toxic nature, it becomes evident that any human presence on the red planet must be accompanied by robust mitigation strategies and precautionary measures to shield against the potential health hazards arising from the soil's composition. Recurring slope lineae and briny water. One of the intriguing features observed on Mars is the recurring slope linear, which strongly suggests the presence of salty water on the planet's surface. Elon Musk's SpaceX missions and NASA's exploration efforts have played a vital role in uncovering this fascinating discovery. RSLs are dark, narrow streaks that appear during the warmer seasons on Mars and gradually fade away during colder periods. The recurrence of these features implies a seasonal flow of liquid, leading scientists to hypothesize that salty water might be responsible for their formation. Detecting salty water on Mars holds significant implications for several reasons. Firstly, it raises the possibility of the existence of a limited water cycle on the planet, which is crucial for the potential habitability of Mars, as liquid water is considered a fundamental requirement for life as we know it. Additionally, the presence of salty water offers a valuable resource for future human exploration. Water is essential for sustaining life and can be used for drinking irrigation and the production of rocket propellant through the process of electrolysis. The discovery of these recurring slope linear features underscores the potential availability of a crucial resource that could support human missions to Mars. However, it is essential to exercise caution and ensure thorough investigations are carried out before determining the extent and accessibility of Martian water resources. The RSLs and salty water findings warrant further study and analysis to determine their exact composition, origin, and accessibility for potential human utilization. Future missions, including the proposed Mars sample return missions and the upcoming Artemis program aiming to establish a sustainable human presence on the Moon, will pave the way for advancements in our understanding of Martian water resources. These endeavors will provide invaluable data to guide future exploration and potential colonization efforts. The discovery of recurring slope linear features and the presence of salty water on Mars have revealed a captivating aspect of the planet's geology and the potential for liquid water in its environment. As we continue to unravel the mysteries of Mars, these discoveries fuel our curiosity and drive us towards a deeper understanding of the planet's past, present, and future. Mysterious methane disappearance. Interest surrounding Mars deepens as scientists not only detect the presence of methane spikes, but also grapple with a perplexing occurrence: the abrupt vanishing of methane from the planet's atmosphere. The identification of methane on Mars has marked an exciting milestone, offering the potential for biological or geological activity. However, the mysterious disappearance of methane introduces an additional layer of complexity to this puzzle. Recurring observations have shown that methane levels on Mars exhibit fluctuations over time, featuring periodic surges followed by rapid declines. The underlying reasons behind this enigmatic disappearance remain elusive, inciting intense scientific debates and speculations. One plausible hypothesis suggests that the brief lifespan of methane, combined with its interaction with sunlight and other atmospheric processes, might account for its rapid dissipation. It is conceivable that Mars possesses mechanisms capable of swiftly removing or transforming methane, thus preventing its accumulation in the atmosphere. Alternatively, the disappearance of methane may hint at transient or localized sources. These sources could release methane intermittently, causing the observed fluctuations. Identifying these sources and comprehending their nature could yield crucial insights into the geological or biological processes taking place on Mars. To further investigate this mystery, upcoming missions will concentrate on the prolonged monitoring of methane levels, mapping its distribution across the Martian surface, and searching for correlations with geological features or potential habitats. The forthcoming Mars Sample Return mission, designed to gather Martian samples for analysis on Earth, promises to shed more light on this intriguing phenomenon. Understanding the patterns and causes behind the enigmatic disappearance of methane holds immense significance for our quest to uncover the secrets of Mars. It not only aids in assessing the planet's potential habitability, but also offers valuable clues regarding its historical and current processes. The existence of quakes. In recent years, the efforts led by NASA's exploration missions have unveiled compelling evidence that Mars is not as inactive as it may initially appear. This evidence takes the form of seismic activity, colloquially referred to as Mars quakes. These seismic events have been successfully detected, demonstrating that the red planet experiences geological tremors akin to Earth's earthquakes. Through the strategic deployment of seismometers on the Martian surface, scientists have meticulously recorded subtle yet discernible vibrations stemming from these Martian quakes. The existence of these Mars quakes offers valuable insights into the planet's internal composition and geological processes. Delving into the study of these seismic phenomena enables scientists to gain a deeper understanding of Mars's crust, mantle, and core, thus shedding light on its tectonic behavior and the potential for volcanic eruptions. By scrutinizing various attributes of Mars quakes, including their frequency, magnitude, and epicenter locations, researchers can construct a more comprehensive geological model of the planet. This, in turn, paves the way for further investigation into this intriguing natural phenomenon. Future missions are poised to prioritize the deployment of more advanced seismometers and the expansion of the monitoring network on Mars. The Phobos monolith. One of the intriguing discoveries made by NASA's exploration missions is the identification of a peculiar structure on Phobos, one of Mars's two moons, known as the Phobos monolith. This enigmatic monolith has sparked curiosity and speculation regarding its origin and significance. The Phobos monolith stands as a substantial obelisk-like object protruding from the surface of Phobos. Its distinctive appearance and remote location have drawn comparisons to monoliths featured in science fiction, and have given rise to various theories regarding its existence. Scientists are presently engaged in an investigation into the nature and composition of the Phobos monolith. Some suggest that it might be a naturally occurring geological formation, shaped by asteroid impacts or other erosional processes, while others contemplate the possibility of artificial origins. This opens the door to questions about potential extraterrestrial intelligence or ancient civilizations on Mars. Now it's time for today's subscriber pick. What NASA just found on Mars terrifies the whole world. Numerous websites have featured an image that some suggest might indicate the presence of extraterrestrial life on Mars. While the idea of life on Mars has fascinated people for centuries, recent photos taken by NASA's robot Spirit have tentatively supported this theory. Accurately identifying features on Mars is inherently difficult due to its distance, roughly 35 million miles away, which limits the effectiveness of even the best telescopes. To explore Mars, NASA has sent robotic missions equipped with cameras. The phenomenon of recognizing figures in the Martian landscape is akin to the way people often see faces or familiar shapes in clouds, highlighting how our minds can sometimes generate misleading illusions. Let us know what you think about what we just showed you. The dynamic evolution of a neighbor world. Exploration missions, spearheaded by figures such as Elon Musk and NASA, have unveiled intriguing and puzzling disparities in the levels of oxygen within the Martian atmosphere. These unexplained oxygen fluctuations, observed at different times, offer a captivating yet bewildering phenomenon. Observations conducted by orbiters and rovers have revealed that the volume of atmospheric oxygen on Mars undergoes significant changes over time. Despite these compelling findings, the underlying causes of these fluctuations remain uncertain. One plausible explanation could involve dynamic chemical reactions or unfamiliar biological processes occurring on the planet. The presence of oxygen in the Martian atmosphere holds significant scientific interest due to its vital role in supporting life as we understand it. Nevertheless, the fluctuations in oxygen levels pose substantial challenges to the potential habitability of Mars and the feasibility of sustaining future human missions to the planet. Through meticulous observations and thorough analysis, scientists have uncovered traces of ancient geological activities which point to dramatic and catastrophic incidents in Mars's history. The presence of extensive impact craters, such as Hellas Basin and Argyre Basin, stands as clear evidence of past cosmic collisions with Mars. These impacts had profound effects on the planet's surface, leading to massive upheavals, seismic activity, and the formation of distinctive geological features. Additionally, the existence of colossal volcanoes like Olympus Mons suggests intense volcanic eruptions in the planet's history. These volcanic activities released vast amounts of lava, reshaping the Martian surface and leaving behind unique volcanic structures. The identification of evidence for past cataclysmic events on Mars offers valuable insights into the planet's geological evolution and underscores the dynamic nature of our neighboring world. Additionally, it prompts questions about the potential impact of these events on the planet's climate, habitability, and the potential for ancient life. Geological oddities or signs of ET intelligence? One of the most fascinating and debated aspects of Mars exploration, led by individuals such as Elon Musk and institutions like NASA, revolves around the speculation concerning possible extraterrestrial artifacts on the planet. While no definitive evidence has been uncovered, the various missions to Mars have sparked imaginative discussions and theories regarding the potential existence of ancient alien civilizations. Images captured by rovers and orbiters have occasionally unveiled peculiar formations that some enthusiasts interpret as remnants of intelligent design. These alleged anomalies encompass a wide range, from unusual rock formations to structures that resemble ancient ruins or even potential artifacts. However, it is crucial to approach these speculations with a scientific mindset that embraces skepticism. Many of the phenomena observed on Mars can often be attributed to natural geological processes, including erosion, wind patterns, and impact cratering. These features, while intriguing, can typically be explained by mechanisms already known on Earth. While the quest for alien artifacts on Mars certainly ignites excitement and curiosity, it is of paramount importance to approach the subject with scientific rigor and critical thinking. Scientific exploration requires an evidence-based approach, which allows us to distinguish between genuine anomalies and imaginative interpretations. The threat of perchlorates. NASA's exploration missions have unveiled a significant concern for human endeavors in Mars exploration and colonization: the presence of perchlorates in Martian soil. Perchlorates, being highly reactive chemical compounds, possess the potential to have negative impacts on human health and create obstacles in establishing sustainable habitats on the red planet. These compounds are toxic to humans and can disrupt the normal functioning of the thyroid gland, affecting hormone production and metabolism. The detection of perchlorates in Martian soil poses a substantial challenge to the safety and welfare of future astronauts. Addressing the threat of perchlorates necessitates innovative solutions, and scientists and engineers are actively researching methods to eliminate or neutralize these compounds. This is vital to ensure the suitability of Martian soil for agriculture and human habitation. Various techniques, such as chemical treatments, thermal processing, and biological approaches, are currently under exploration to mitigate the risks associated with perchlorates. As we continue to strive toward the exploration and potential habitation of Mars, it is imperative to address the perchlorate threat. By developing innovative methods to remove or mitigate the effects of these compounds, we can lay the foundation for a sustainable human presence on the red planet, all while safeguarding the health and well-being of future explorers. Springtime on Mars. The high-resolution imaging experiment, commonly referred to as HiRISE, is observing the arrival of spring on the Martian surface. It's important to note that spring on Mars differs significantly from spring on Earth due to unique features. Mars is characterized not only by permanent ice caps, but also by seasonal polar caps made of carbon dioxide, which we recognize on Earth as dry ice. The seasonal polar caps on Mars take shape each winter as atmospheric carbon dioxide transforms directly into frost, forming a layer of dry ice across the Martian surface. As winter gives way to spring, rising temperatures cause the solid carbon dioxide to transition directly from ice to gas. The accumulation of pressure beneath the carbon dioxide ice is a fundamental distinction between this process and the springtime thawing of frozen water on Earth. On our home planet, when warmed water ice and snowpacks melt, they typically transform into liquid and either run off between frozen layers or seep into the ground. In contrast, the high-resolution images from HiRISE reveal the presence of fan-shaped deposits of dust forming captivating starburst patterns. This dust has been transported from beneath the seasonal ice cap by jets of escaping carbon dioxide emanating from radial troughs, often colloquially referred to as spiders, due to their distinctive shape. Scientists have unearthed an astonishing revelation on Mars, which has captured the world's attention for a valid reason. While Mars was not anticipated to host any residential complexes, it has sparked speculation about potential Martian inhabitants. If life does exist on Mars, it is plausible that habitation would be concealed beneath the planet's cracked surface. This phenomenon has led to contemplation about glimpsing into the future, envisioning a colonized Mars. The concept of colonizing Mars has piqued the interest of both public space agencies and private corporations. It has been extensively explored in various forms of media, including science fiction literature, film, and art. Numerous organizations have proposed plans for human missions to Mars, representing the initial step towards colonization. However, no human has yet set foot on the planet, and there have been no return missions. Can you envision yourself establishing a home on the red planet? Let us know what you think in the comments below.